systems for people with lots and lots of data. We love those kinds of folks. And just a real quick question. Is there anybody here that has a plan they need to get to right away?
Too bad.
Okay, good. Nobody here is doomed. No, I'm pretty lightweight, so I won't be up here too long, I promise. So what I thought I would do is, because we're mostly a West Coast-based firm, we have clients up and down the coast. I thought I would cover a project that's going forward in Southern California. And so let's go ahead and meet today's friend. Let's meet Ben. So Ben hasn't, Ben's right over there. Hey Ben, thank you. So hopefully by next year, I'll get the photo shoot done with Ben. So you can see that Ben is a different person.
Wait.
I know, no.
Every day.
I believe that. But in this case, Ben is an IT manager. He works for a media company. And Ben is a damn thinker. And the problem here is that Ben, being an IT manager in media, means he spends most of his life worrying about or trying to worry for other people about digital asset management. So just one more quick show of hands. Anybody here think half of their life is consumed by digital asset management? Or trying to get people to clean them up after themselves? Who should be? Right. So that's Ben's life. And so Ben works really hard, and occasionally Ben even gets to sleep. Right? So now one would ask, what is it that keeps Ben awake? Well, for one thing, those around him have a lot of expectations. They think that technology just works. Now those of you in operations and production know that that's not the case. So what we have to do is nail down how is it that we can make Ben feel a little bit better and get rid of the chaos in Ben's life. So Ben has some core issues around this thing called data, right? And so when he looks at the world, he sees that he's got too much data coming in. There's a lot of variety, so he has trouble understanding what it is and categorizing it so he can get rid of it, right? And a lot of it's coming a little bit too fast, right? So when Ben worries about data, he nails down 4 areas: inventory, placement for performance, efficiency, and security. And we will definitely be talking about security. So the first part is inventory, right? Everybody knows that iRODS is fantastic at understanding it, but in the world of media, there are a lot of issues around inventory because the world for them has become a file. Their product is a file. Managing those files is critical to their business success and their reputation because they do a lot of work on just QCing things before they ship them. And so the integrity of that file, the management of that file, and delivering the right file is really important. So beyond that, he has to know what do they have and do they really have it, because people will tell him he has it when he doesn't have it. Next is he needs to know where it is. Sometimes they're right, they do have it, they just can't find it. Who touched it is one of those big security things. Hollywood's a little sensitive about who sees what. Not as bad as the government, but they still have some issues. And then the core thing is they have a pipeline that's not infinitely large, just like most of you. That means some of the data has to leave to make room for the data coming in. Identifying which is the candidates would be crucial to making their production cheaper to execute on, right? So then on performance and placement, he's got additional issues. He's got multiple sites. He's got at least 3 sites where he's doing production processing, and then he's got a core site where he tries to archive things and keep it in a central location. It doesn't work. He's got distributed processing. He also has limited bandwidth from site to site, and of course, everybody always wants to do processing on fast storage. They never want to put it on tape because it takes too long to get back, and so their objective is to have durable, cheap storage seamlessly in the middle of this equation. And then he gets to deal with a very interesting CEO who thinks everything would be much better if it was free, but does write checks. But is very concerned about anything that goes into the environment be easy for the teams to work with, be invisible to the operations that they already have in place, and that the time to access, and that's a dual thing, right? We're not just talking about tape, like first byte. We're talking, can I find it? First off, where is the data? Once I know where it is, how long does it take me to get to it? Because if it's in another site, again, that's a problem. I may be pulling 8K resolution files across a link that doesn't want them. So then the security focus. Why? Well, you know, this industry has had some reputational issues with security. Does anybody remember the Sony event from, must be about a year ago? Really? All right, well that one's worth exploring. And for those of you who never poked into it too far, I think it was 47 pieces of malware used in concert to take down one of the 6 major studios. That was a concerted effort. It was not random hackers. So security is pretty important to the media industry, and so when they look at it, they know that they've got 3 key issues they've got to deal with. Trusting who they're working with, the boundaries that they've set up for security, and machine attacks, meaning they know they're not just fighting people, they're fighting people that have machines at their disposal. So on the trust factor, the key is contending with bad actors. A bad actor is somebody who has bad intent for you. Now, they always pose as good actors, and I was trying to find a great image to go with this, and I couldn't resist. Right? I love Star Trek, but at some point one has to admit the reality of the situation. And so the reality of the situation in security is that there's a lot of fakeness, and identification is one of the core things lacking in many of the environments. They don't even use multi-factor authentication in media to a large degree. So the first thing was, how are we going to deal with bad actors? The second is boundaries. At this point, media doesn't believe in boundaries anymore. There are no boundaries for them. First off, Sony exposed the fact that you can have a lot of people running around inside your infrastructure doing nasty things. The second is that most of the time the data is flowing from site to site to site between one company and another. Small companies that may or may not have passed an audit or just faked it when they did. And so being able to secure the data as far as possible, even outside the boundaries of my environment, becomes important. And then lastly, machinery. So we can scale very fast things. So can the bad people. So how is it that we're going to go ahead and fight fire with fire in this case? So,
what should Ben
do? Well, I am at an iRODS conference. So, the project that went forth was to create a secured version of iRODS that would provide all those key elements they needed in media, right? And so there's a lot of variants here that are blessedly created by the framework from the team, so thank you very much. And then we just do a little addition here and there because you're making it easier and easier to do that. So on the front of inventory, right? So of course everybody knows the beauty of iRODS in that area. We've done a couple of extra things to it that we think are very useful. So one, and this came out of a conversation from practically a year ago about how do you identify a file? And we've settled on a system called C4, which actually came out of the film industry. So it came out of the Entertainment Technology Center at one of the major universities. And C4 is a way to hash a file, then encode it with a specific file naming sequence so that that file name is unique to that file. If you change one bit in the file name will change. And it is identifiable across all elements, and it is text and machine friendly. So C4 has become our standard for ingest. Anytime a file comes into the grid, it's going to get a C4 identification marker on it. The second thing we do is insert the option to compress and encrypt. Those are 2 painful things to do, but thankfully Intel is making that much faster and easier. So there's different ways we can do it. It's a pluggable system at this point. One of our favorite technologies has the ability to do lossless compression at high throughput and with good results, and has passed the visual test of the American Cinema Society so that they look at it and go, "That looks fine to us," which is really hard to get them to say that. I mean, as soon as you say the word compression in the film industry, people's hair goes on end, right? It's almost a religious war. So this has made it past on that. There are certain elements, of course, just to call out, right? We're trying to figure out what and where and who and when. It's just the basics of what iRODS does helps us with that immensely. And so phase 1 is just getting iRODS to do the basics across the entire infrastructure, right? Because the more insights they have, the more efficient they're going to get. We just grow from there. So that helps inventory. Placement and performance, what we find is that if we ingest into what we call production storage or performance storage, use that as basically a cache layer while the processing takes place, simultaneously copy the data off to cheap and durable storage where it can sit for weeks, or more likely months, because nobody wants to make a decision. Then the resource and the allocation to the company is really much more efficient, right? So the CEO doesn't have to write a really big check to somebody like Panasas. Now, I'm sure David would like that, but storage, it's not that big of a check. But it's cheaper than like, you know, erasure-coded 20 watt. Yeah. And so we just have to admit the reality there. So using a workflow that uses performance storage like it should be used for when it needs the performance, and then shovels off the data to a more cost-effective mechanism, allows the company to compete in the marketplace and deliver the impossible, which is what all Hollywood people ever ask. And then we can also do multi-site arrangements, so based on the policies on what kind of job is going to be run, we make sure that the data is located in the right facility to get the job done effectively. So we're helping there. We're helping with performance and the placement of the data. Third, security. So this one goes a little bit deep. So let's just dive in. So multi-factor authentication is tied off of the ICAT itself, but then we're also doing compression and encryption with an external key manager. So the ICAT does not store keys, but the ICAT stores a hash for what it needs to ask for. And we can do this on the fly so that we can do one-time keys, and then if you need to send data out of the grid or out of the secure file system, we can send it out in an encrypted form with its own unique key, which is identified in the catalog as another copy. So then if we have a client on the outside that wants to decrypt it, we know when they want to decrypt it because they have to come back and get the key. So it works well. So the multi-factor authentication, again, not just name and password, but name, password, another ID, and geolocation is the target by the end of the year. So that helps with bad actors. On the boundaries, so I touched on it a little bit. It's an option, not fully used at this point, to encrypt the data and store it within the system in an encrypted state throughout. Then we only decrypt when we need to, or if we need to send the data to a remote location, we can tag whether or not that location is authorized to have unencrypted data. So that's the architecture that's going forward. And then this is just to highlight, building a big wall around your city doesn't work. And the only mechanism that we found that's reliable is to have the data protect itself. The only way we can do that is with encryption at this point, which is becoming increasingly cost-effective to do. And then lastly, so thanks to the new 4.2 audit functionality coming out with lots and lots of verboseness, we can pipe that directly into what's called a SIM, which is a Security Incident and Event Manager, which then does threat analytics. And so there's multiple ones on the market. We have one because it's not, we like it because it's not so noisy. So it's not always sending out false alarms. But this can then look for patterns as to the behavior of file access, either ingest or specifically reads, which is something that I'm sure that major studio that got hacked would have really liked to have had, because a lot of files were being accessed that frankly shouldn't have been. That would show up as an alert. Lastly, on the efficiency, we talked about how we can use different classes of storage to optimize and place data based on what the workflow and the pipeline is dictating. The other benefit to this, and this is just my perspective on it, I don't want to open a big discussion on this one, but fast storage tends to be configured in such a way that it's not as durable. But I tend to, in my professional life, leave data on fast storage as short a time as possible. So the extra benefit by having this efficiency around cost is that I can also be more efficient about security, and I can put data that's going to sit for weeks or months or longer on really durable storage, because it becomes more cost-effective to do. I don't care as much about the performance there. Again, you can go even a little further. So if you're using an S3 connector to get to all of that durable storage, then I could have data protection from multiple sites, or I can do what's called geospreading. If you're not familiar with geospreading, it's basically using erasure coding to spread across sites, not just drives. And frankly, if I can geospread through one S3 connector, that's nice and simple. And so, because this was a story about Hollywood, it should have a happy ending, right? So of course, Ben has no more worries. Ben can sleep because now Ben has solved his inventory problems, his placement and performance issues. He's got greater efficiency. The CEO gives him a raise, and he's as secure as he can be, which is really hard to do in this world. And so that's pretty much it on checking all the boxes for what we were trying to do on the project. Of course, and I shall admit this, that no project rolls out perfectly on time and completes every tech box there is. So this will be a work in progress that I hope to tell you more about next year. And I would also like to thank the iRODS consortium for having the framework in place to let it go forward in the first place. HTST is always wonderful on their support. FireEye is the back end for threat analytics, and Pixspan is that interesting compression technology for doing lossless compression at high speed. And with that, that's all I really had to say. Any questions?
Did you write a microservice for generating those C4 IDs or?
No, Tyson.
Okay.
And there's actually a couple of questions about that I need to ask you later.
So the stuff that you ship to FireEye, is that like a standard offering from them, or are you just sort of building something new, given that the data that you're sending is not sort of the standard run-of-the-mill
Well, it's a new feature, and we are having to go through a bridge technology to get there. So FireEye doesn't take it in directly, but we can convert it to a log format that it can suck in.
Yeah, because at one point we tried it with them and they ran away, so I'm glad they don't.
We do some pre-filtering. Question?
So the encryption, can you decouple the key and send an encrypted file to someone and then give them the key?
Yes.
You determine, is that the way you do it, or do you always unencrypt before you send it out?
It depends on the site where it's going. So our preference is to send an encrypted state and send the key through another mechanism.
And let them worry about it?
Correct.
Right, let them do it.
But that doesn't always work, right? Not everybody is technically adept at dealing with that.
Right.
And production deadlines are notorious for, oh, just ship it.
Oh, yeah. So, Turnabout Intruder, that's where the picture of Kirk came from there. That's the actual episode. And when will Warp Drive be ready, since you're at the Daystrom Institute?
Oh, we've already gone to Transwarp.
Transwarp, okay, we're there then. Let's go.
When you disseminate the data, you're unencrypting it using the key from the key store, and then re-encrypting it with the new temporary key? Is that what's happening?
Correct, so it's double.
And so is that registered as a separate replica then?
It is.
Okay. Well, and you're annotating that replica with, or, well, I guess the whole data object with that temporary key.
Correct, but we're doing something strange on the backside at the moment, which I would like to sort out with you.
Okay.
So you offloading the compression to a separate appliance or engine, or are you doing it off the resource servers?
So it is going through the resource servers now in the current format, but that's going to change. The trip through the AES encryption library on the Intel processors isn't horrible, but it's not friendly either.
So I remember when this came up as a good idea, and it all seemed glorious. What was the hardest or most surprising, or both, part of getting to where you are now, from the idea at the beginning?
It all felt like a lot of rocks that kept rolling back down on us. And that was not all generated by the technology either, right? So you have a lot of other factors in the media environments, from pressure and resource and people, and can we move forward? So technically, I'm just going to say it was us ramping up on iRODS and really looking forward to leveraging 4.3's functionality when it comes out, but just becoming more adept at 4.2. So there were certain things that we tried and then didn't work out, so we put those on the shelf.
Sure.
Waiting for 4.2. Well, then I think that's a wrap. I'll give the mic over to Regan.